13.8 billion years ago, the universe began. In a single moment there was nothing, and in the next instant there was everything. Time and space were born in an explosion of energy and matter so vast that it defies our logical understanding. Entire galaxies emerged from absolute void, while gravity began to shape the first stars, and light overcame primordial darkness. Fundamental particles danced in a chaos of high temperature until cooling allowed the formation of everything we know today. This is the narrative that science has told us for decades. An elegant model based on observations of radiation and complex mathematics that seem to explain definitively the origins and workings of the cosmos. But what if I told you that the farther we look, the more the pieces stop fitting together? What happens when our most precise instruments begin to show something that should not be there? Get ready, because we are about to enter a territory where reality challenges theory, and what we know about the beginning of everything may be about to change drastically. The universe is a mechanism of absolute precision, governed by laws we have been trying to decipher since we first looked at the sky. We believe we understand the expansion of space and the journey of light across billions of years. Yet we are facing an unprecedented observation conflict. Our theories about the beginning seemed complete until we decided to look farther and with greater clarity. This is the great paradox of modern astronomy. On one side we have particle physics, describing quarks and the Higgs field in perfect symmetry. On the other, we have the images sent by telescopes that seem to tell a different story about the age of galaxies and the speed at which everything moves away. There is a growing tension between what the calculations predict and what the lens captures. We are living a moment when science does not merely seek to confirm what it already knows, but to survive its own discoveries. The great question that crosses the borders between physics and philosophy is how something can arise from nothing. Everything we know depends on mechanisms of cause and effect. We seek reasons for things to be as they are, but at the most fundamental level, we still do not know the how or the why of the entire universe having come into existence. Was there really nothing before time? As Stephen Hawking suggested, considering space and time as inherent properties means that looking for something before the beginning would be as meaningless as looking for something north of the North Pole. Or perhaps there was no real beginning, but only a limit to what we can observe. Scientists believe that a period of exponential expansion called inflation was what put the bang in the Big Bang. That event set the stage for everything that would follow, creating the density fluctuations that became the seeds of the great structures we see today. Imagine the universe as an elastic fabric that stretches infinitely, carrying with it the light of past eras. When we look into the depths of space, we are literally looking into the past. The light from the most distant stars took billions of years to reach us, carrying information from an era when the cosmos was young and dense. For a long time, the Hubble telescope was our main messenger from this ancient era. It showed us galaxies in formation and the accelerated expansion driven by mysterious dark energy. But Hubble had a limit. It saw mainly visible light and part of the ultraviolet. The light from the first stars, however, underwent a redshift so extreme due to the expansion of the universe that it became invisible to those sensors, turning into infrared light. To capture the first glow of creation, we needed something new, something capable of sensing the residual heat of objects at the frontier of time. That is how the James Webb Space Telescope was born, a $10 billion engineering marvel designed to be humanity's definitive eye. It is so large that it had to be folded like origami to fit inside a rocket. Its sensitivity is such that it must operate at temperatures close to absolute zero so that its own internal heat does not blind the sensors. With its gold-plated mirror, Webb was sent 1.5 million kilometers from Earth on a bold mission to observe the first stars and galaxies that formed right after the Big Bang. The goal was simple: validate our cosmological models and fill the gaps about how matter organized itself at the beginning. But what the first images revealed was not just beauty, but a fundamental problem. James Webb saw galaxies that are too large, too mature, and too old to be there according to our current chronology. This conflict between what mathematics predicts and what the telescope shows created a crisis in cosmology. If galaxies were already massive and structured only a few 100 million years after the Big Bang, then perhaps time did not pass the way we imagined, or perhaps our understanding of gravity and dark matter is incomplete. James Webb did not just give us sharper pictures, it gave us a puzzle whose pieces seem to belong to different games. We are at a crossroads where technological progress has allowed us to see the truth, and that truth is uncomfortable. It forces us to question whether our map of the universe is a faithful reflection of reality or just a limited interpretation based on tools that are no longer sufficient. As we advance on this journey, we will explore how particle physics tried to create a theory of everything and how direct observation of the deep sky is challenging those foundations. We will investigate the strange discoveries about the matter and energy that make up 95% of everything that exists but remain invisible and silent. The universe is not just a place of stars and planets, but a battlefield of ideas where human curiosity fights against the immensity of the unknown. What James Webb saw at the edge of everything changed the game forever. And what you are about to see is how this new vision is rewriting our own history from the first atom to the last galaxy. To understand the magnitude of what James Webb is revealing, we must first accept how strange the foundation of our reality is. Everything you see around you, the mountains, the air you breathe, and the stars that shine in the firmament, are made of a matter that follows rules established in the first microseconds of creation. Particle physics tells us we live in a universe of symmetries, but one of those symmetries had to be broken for us to exist. In the beginning, there was an invisible battle between matter and antimatter. By logic, they should have annihilated each other completely, resulting in a universe full of nothing but pure radiation. Yet by a discrepancy of 1 part in a billion, matter won. That insignificant leftover of particles is what makes up every atom of your body and every galaxy in the sky. It is fascinating to think that our existence is the result of a miscalculation of nature or a primordial asymmetry that we still cannot fully explain through our field equations. The standard model of cosmology suggests that the universe went through a phase of violent expansion of inflation that smoothed space and distributed energy. Imagine a balloon being inflated so rapidly that any roughness on its surface disappears instantly. That would explain why the universe appears so uniform in all directions, but that uniformity hides disturbing secrets. When we analyze the cosmic microwave background, the thermal echo of the Big Bang, we notice that the temperature fluctuations are small but crucial. They are the seeds of gravity. Without those infinitesimal variations, matter would never have clumped to form stars. The problem is that James Webb is finding galaxies that seem to have ignored that maturation time. They are like adults emerging in a nursery. According to hierarchical formation models, galaxies should start small and irregular, merging over billions of years to become majestic spirals. But Webb found massive, bright structures already present when the universe was only 3% of its current age. This leads us to a deep questioning about time and the speed of cosmic evolution. Did gravity act more efficiently than we predict, or is there a missing ingredient in our recipe of the universe that accelerated the clumping of matter? Dark matter and dark energy are the silent protagonists of this plot. We know that visible matter is only the tip of the iceberg, representing less than 5% of everything that exists. The rest is a substance that does not emit light and a force that pushes galaxies away from each other. For decades, we have worked with the idea that dark energy is a cosmological constant, a fixed value that determines expansion. But if James Webb continues to confirm the existence of these impossible galaxies, we may have to consider that dark energy, or the very nature of gravity, changed over time. The Hubble tension is another symptom of this crisis. Different methods of measuring the expansion rate of the universe give different results. When we look at the primordial universe through the background radiation, we get one value. When we measure the distance of nearby supernovae, we get another. James Webb was sent precisely to resolve this discrepancy by providing unprecedented precision measurements for variable stars in other galaxies. What we are discovering is that the error is not in our instruments, but possibly in our physics. There is something fundamental we are not understanding about how space stretches, as if we were trying to read a book where some pages were glued and others are written in a language we have not yet decided. The precision of James Webb is not closing the discussion, but rather exposing the cracks in the edifice of modern science. When we observe galaxies like Jade's G's Z13-0 that existed only 320 million years after the Big Bang, we are forced to admit that the primitive universe was much more productive than we imagined. Those galaxies are full of the population of 3 stars, the first luminaries of the cosmos, which were composed only of hydrogen and helium, and were hundreds of times more massive than our Sun. Those stars lived fast and died violently, seeding the universe with the heavy elements necessary for life. Webb allows us to see the exact moment when the first light broke through the fog of neutral hydrogen in the so-called ionization era. It is a journey through time, where each image pixel represents thousands of years of stellar history. But that abundance of light in such a remote era suggests that the engine of creation was operating in a much higher gear than supercomputer simulations predicted. Moreover, the question of supermassive black holes at the center of these early galaxies is an enigma apart. How can a black hole reach billions of solar masses in so little time? They should not have had enough time to swallow matter and grow so much. This suggests that perhaps they were born large through the direct collapse of immense gas clouds, skipping the stage of being small stars first. The universe seems to be in a hurry to become complex. That hurry challenges our perception of slow and gradual development. What James Webb is showing us is a vibrant and already highly evolved cosmos where we expected to find only chaos and darkness. Each new discovery pushes us closer to a scientific revolution where the names of Einstein and Hawking may be joined by new theories that unify what now seems contradictory. Space is not just a void, but a dynamic field where virtual particles constantly appear and disappear. This vacuum energy is theoretically immense, but observationally small, creating the largest prediction error in the history of physics. The search for understanding this energy is what drives us. If James Webb detects variations in how galaxies recede in different eras, we may finally understand whether the destiny of the universe is eternal expansion to absolute freeze, or whether there is a return mechanism we do not yet comprehend. Cosmology has ceased to be a science of speculation to become a science of high precision, and precision is telling us that the universe is much stranger than our minds are currently able to conceive. In this immensity, we are merely observers on a small blue dot, trying to understand the ocean of time that precedes us. James Webb is our bridge to the past, but also the mirror that reflects our intellectual limitations. With each processed image, each analyzed spectrum, we are writing a new chapter. It is not just about astronomy, but understanding our biological origin through the chemical origin of the stars. We are stardust that learned to build instruments to look at the stars from which it came. And what we are seeing is that our home, the universe, is a place of constant surprises, where the impossible happens routinely, and where the beginning may have been only the first step of a dance much more complex and ancient than we dared to dream. We now stand before an abyss of knowledge. James Webb has taken us to the edge of the visible, and what we found there makes us question everything we believed was settled. The next step is not just to observe more, but to think differently. The crisis in cosmology is not a failure, but the clearest sign that we are about to make a monumental discovery. The universe is challenging us to be as bold in our thinking as we were in building the telescope that observes it. The final frontier is not space, but our ability to accept that reality may be radically different from what our textbooks teach. The true delivery of this first cycle lies in the understanding that James Webb is not just a telescope, but a machine for falsifying obsolete theories. When we look at the images captured by Webb, we realize that the universe did not have a timid and disorganized childhood. On the contrary, it seems to have skipped stages. The galaxies that should not exist are challenging the chronology we established with such care. This puts us in an uncomfortable but exciting position. We are facing the proof that our narrative about the Big Bang, although correct in its mechanical foundations, failed to predict the speed and efficiency of the organization of matter. The delivery here is the perception that physical reality is much more plastic and surprising than our mathematical models allow us to suppose. James Webb delivered to us a universe that is simultaneously older in appearance and younger in chronology, creating a paradox that only a new physics could resolve. This introduction serves to consolidate the idea that the journey we will begin in the next cycles is not just about astronomy, but about the reconstruction of our understanding of reality. The conflict between the thesis of the mathematical perfection of particle physics and the antithesis of direct observation of impossible galaxies will be the engine that takes us to a new synthesis. What James Webb saw at the edge of everything was not the end of the road, but the beginning of a new era of discovery, where each answer generates a dozen new questions. The universe is calling us to a deep revision, and from now on, we will dive into the technical and theoretical details that explain why these galaxies are so problematic and what they tell us about the final destiny of everything that exists. As we close this introduction, we need to fix the concept that light is our only tool of investigation, but it is also a limitation. James Webb overcame the barrier of the visible to show us the infrared, but in doing so, it revealed that what we considered the final horizon was just another curtain. The closing of this cycle marks the transition from initial curiosity to rigorous investigation. We are no longer just marveling at the colors of nebulae. We are concerned with the mass of galaxies and the density of primordial gas. The silence of James Webb before the void is in fact a cry of alarm for the scientific community. The standard model is under pressure, and the beauty of the images is just the wrapping of a gift that contains the greatest intellectual challenge of our century. Get ready for the next step, where we will leave the generalities and enter the subatomic world. We will understand how fundamental particles gained mass and how that small initial asymmetry allowed millions of years later a telescope to be built to look back at the beginning. The loop was opened, the universe observed itself, and what it saw was something no one expected. The stage is set for the thesis. We will explore the world of quarks and the Higgs field to understand how the theory tried to predict what James Webb now puts in question. The journey to the heart of matter begins now, and the answers may be much stranger than any science fiction dared to imagine. The impact of these discoveries reverberates not only in the laboratories, but in our perception of place in the cosmos. If galaxies form so early and so robustly, the probability of life having arisen elsewhere and at other times increases drastically. James Webb is telling us that the universe is a fertile place and ready for complexity from its first breath. This closing is an invitation to abandon certainties and embrace methodical doubt. What we know is a drop, what we ignore is an ocean, and it is in that ocean that we will sail from now on, seeking to understand how matter and energy dance on the stage of space and time, challenging gravity and our own logic. Finally, we must reflect on human persistence. It took us decades to build Webb. We faced hundreds of failure points, and we invested fortunes to see a little farther. This search for answers is what defines our species. The closing of this initial cycle is a tribute to that will to know. Even if the impossible galaxies break our theories, the will to rebuild them remains intact. The universe may be vast and mysterious, but it is not mute. It speaks through light, and James Webb is our best translator so far. What it has told us so far is that the beginning was much more grandiose than we thought, and that the middle of the story still holds secrets that will make humanity rethink its own existence. With this, we conclude the preparation for the deep dive. The scenario was described, the tools were presented, and the problem was exposed. The conflict of observation is our guide. From here, each sub-cycle will take us one step forward in the attempt to reconcile what we see with what we think. The universe does not owe us simple explanations, but we have the obligation to keep looking for them. The first light was detected, the first galaxies were mapped, and the cosmological crisis was declared. What follows is the attempt of human reason to tame primordial chaos through the thesis of particle physics. Join me in this exploration where the micro and the macro meet in the greatest laboratory of all, space-time itself. The next part will be the moment when mathematical elegance will try to explain the origin of mass and structure. It will be the clash between the perfection of theory and the rawness of reality captured by the gold of Webb's mirrors. This is the moment to breathe and process the immensity of what was said, for what will follow will require all our capacity for abstraction and analysis. The universe began 13.8 billion years ago, but our understanding of it is only beginning today, with each datum transmitted by the antennas of James Webb. The past is present, and the future of science depends on how we interpret these ancestral lights that have just reached our eyes. To understand the magnitude of the conflict that the new James Webb data imposes, we must first dive into the fundamental architecture of reality. The universe we observe, with its vast galaxies and radiant light, is sustained by a set of invisible rules known as the standard model of particle physics. This is the most precise description humanity has ever built of the basic components of matter and energy. According to this theory, the universe is an immense field of interactions where fundamental particles such as quarks and leptons dance under the influence of forces that define everything that exists. At the beginning of everything, right after the Big Bang, the cosmos was an ocean of pure energy, a plasma so dense and hot that the particles we know today did not even possess mass. They traveled at the speed of light, in perfect symmetry where the distinction between the forces of nature was not yet consolidated. If the universe had remained in that state of mathematical perfection, galaxies, stars, and life itself would never have arisen. Space would be an eternal void of sterile radiation without any solid structure capable of clustering. However, only a fraction of a second after the birth of time, an event occurred that changed the destiny of the cosmos. The breaking of symmetry. Imagine an invisible field that permeates every cubic centimeter of the universe, from the deepest vacuum to the interior of our cells. This is the Higgs field. As the universe cooled after the initial expansion, this field underwent a phase transition, assuming a value different from zero. From that moment on, the particles that had been flying freely began to interact with this field, feeling a kind of viscous resistance that we call mass. It is as if the universe had suddenly become a dense fluid, where some particles manage to slide easily, while others are braked, gaining the weight necessary to become the bricks of matter. This interaction is what allows gravity to act, for without mass, the curvature of space-time that governs the motion of stars would have no foothold. The precision of the Standard Model is such that it predicted with accuracy the existence of the Higgs boson decades before its experimental discovery in 2012. That particle is the physical manifestation of the field that confers mass to the universe. When we look at the smallest scales of reality, we find a mathematical order that seems unshakable. Quarks unite through the strong force to form protons and neutrons, which in turn stabilize with electrons to create the first atoms. This process of construction from micro to macro is the basis of our thesis on the workings of the universe. We believe that by understanding the laws of particles, we can predict how the great galactic structures formed over billions of years. The universe, from this perspective, is a clock whose subatomic gears determine the rhythm of expansion and the density of each nebula. However, this theoretical elegance carries with it a fundamental premise: time. For atoms to cluster into gas clouds, for those clouds to collapse under their own gravity, and for the first stars to ignite their nuclear furnaces, the universe needs time to mature. According to calculations based on the Standard Model and general relativity, the first galaxies should be small, irregular and rare in the first moments after the Big Bang. They would be the result of a slow evolution, a gradual accumulation of dark matter and hydrogen gas. We expected to find a primitive universe composed of rudimentary structures, almost like galactic embryos trying to find their balance in the expanding void. This is the classical view that shaped modern cosmology and gave us confidence that we had deciphered the code of creation. The problem arises when the light from those first eras finally reaches state-of-the-art sensors. The James Webb Space Telescope was designed to capture the infrared glow of those ancestral structures, acting as an archaeologist of time. What it is revealing is not the disorderly nursery that theory predicted, but galaxies that seem to have skipped centuries of evolution. They possess immense solar masses, dense stellar populations, and an organization that challenges the cosmic stopwatch. If particles gained mass through the Higgs field and gravity began to work immediately, why was the result so much faster and more efficient than our best equations predicted? Why does the universe seem to have had a much more vigorous and productive youth than particle physics suggests is possible? This discrepancy does not invalidate the Standard Model, but suggests we are ignoring a hidden engine or a property of gravity that only manifests under the extreme conditions of the primitive universe. There's matter that, left over from a billion years of mutual annihilation between particles and antiparticles, organized itself into complex systems with frightening speed. We are facing a tension between the perfection of quantum physics, which explains how particles arise and gain weight, and astronomical reality, which shows us that those same particles united into mature galaxies long before the rules allowed. James Webb is not just observing stars, it is observing a flaw in our understanding of how mass behaves on cosmic scales. The universe is therefore a battlefield between what we calculate and what we see. The thesis of particle physics gave us a stable and proven model, but the telescope gave us evidence that nature does not necessarily follow the rhythm we imposed on it. Each photon that traveled 13 billion years to reach us carries the message that the origin of structure is more complex than the simple cooling of a plasma. The organization of energy into heavy matter and the subsequent formation of suns and galaxies occurred under conditions we still cannot replicate in our laboratories. We are operating with a map that, although correct in its microscopic details, seems to fail in describing the speed of construction of the macroscopic terrain. The search for this answer takes us back to the heart of the atom and the frontiers of dark energy. If the expansion of space and the creation of mass are processes governed by the same laws, there must be a missing link that explains this galactic precocity. James Webb forces us to revisit every postulate of modern physics, from inflation to primordial nucleosynthesis. It is not about discarding what we know, but about accepting that the universe possesses acceleration mechanisms that still remain in the shadows of our knowledge. The matter that composes us, born from that initial chaos and shaped by the Higgs field, has a history much richer and more mysterious than any current theory is able to contain. We are only beginning to realize that the beginning of everything was an event of complexity and efficiency that challenged our own intelligence. To understand why the recent discoveries cause such astonishment, we need to look at the foundations we built over a century of theoretical physics. Modern science works on the premise that the universe is a system governed by constant and predictable laws, where the behavior of fundamental particles dictates the evolution of the largest galaxies. At the center of this view is the concept of symmetry. We believe that in the initial moments all forces were one and all particles were indistinguishable. Yet we live in a world of clear distinctions, where matter has weight and space has volume. This transition from uniformity to diversity of forms was only possible thanks to what we call the Higgs field, an invisible entity that permeates every point of the vacuum. Without this field, the basic components of the atom, such as quarks, would have no mass. They would be eternally prisoners of the speed of light, unable to cluster to form nuclei, stars, or planets. The Higgs mechanism is essentially the reason why there is something instead of nothing. When the universe cooled enough for this field to stabilize, it conferred physical properties on particles through a constant interaction. Imagine the universe as an infinite field of snow. Some particles, like the photons of light, slide over this snow without any friction, remaining massless. Others, like the quarks that make up protons, sink and feel the resistance of the terrain, gaining what we perceive as weight. This resistance is what allows gravity to begin its work of sculpture. Quantum physics tells us that once matter gains mass, it begins to curve the space around it, creating the first centers of attraction. The central thesis of our current cosmology depends on this order. First, particles gain mass, then gravity organizes them into gas clouds, and finally, after hundreds of millions of years, galaxies arise. This temporal sequence is the backbone of our understanding. However, the depth of the problem lies in the speed with which the universe seems to have operated. The Standard Model is incredibly successful in explaining how quarks unite to form protons, and how these in turn form hydrogen and helium during primordial nucleosynthesis. But this model assumes that the distribution of that matter was almost perfectly smooth. The irregularities were minimal, microscopic quantum fluctuations that need immense eras to grow and become massive objects. The mathematics predicted a slow and laborious growth. We expected the first galaxies to be small, chaotic, and low-luminosity systems, reflecting the infancy of a cosmos that was still learning to organize itself under the laws of thermodynamics and gravity. The discrepancy arises when we confront this thesis with the light that traveled through almost the entire history of time. The data collected show that the formation of structures was not a lazy process. We find evidence of galaxies that already possessed billions of stars at a time when the universe should be only a dark fog of isolated atoms. If the laws of particles are as rigid as we believe, how did they manage to cluster with such efficiency in such a short interval? One hypothesis suggests that dark matter, that invisible component that does not interact with light, acted as a gravitational catalyst much more aggressive than we supposed. It would have created deep gravity wells right after inflation, dragging ordinary matter to centers of extreme density before even what radiation theories allowed. Still, even with the help of dark matter, the numbers do not add up easily. For a galaxy to become mature, it must go through cycles of death and birth of stars, enriching the interstellar medium with heavy elements. What we are seeing are systems that seem to have lived several lives in a cosmic blink of an eye. This forces us to question whether the Higgs field or the fundamental constants of nature had the same value from the beginning. If the strength of gravity or the mass of particles was slightly different in the remote past, the history of galaxy formation would be radically altered. We are dealing with the possibility that the primitive universe operated under high-pressure physics, where evolution that today takes billions of years was completed in a fraction of that time. This deepening into the physics of the infinitely small reveals a crack in our understanding of the infinitely large. The success of the Standard Model in particle accelerators on Earth gave us a false sense of security. We believe that because we understand the behavior of the atom today, we understand the behavior of the universe in the past. But the frontier observations are showing us that the Big Bang laboratory had variables we have not yet been able to replicate or predict. The thesis of mathematical perfection runs into the rawness of visual evidence. The universe is not just a mechanism of particles, it is a system that seems to have a capacity for self-organization far superior to what our equations allow. When we look at the first lights, we realize that the simplicity of hydrogen and the subtlety of the Higgs field were the starting point for an explosion of complexity we did not predict. Time, which we thought was the main ingredient for galactic maturity, may have been secondary to processes of direct collapse and gravitational instabilities we are still trying to map. With each new measurement, the classical thesis of slow evolution becomes harder to sustain. We are being pushed to a frontier where particle physics and cosmology need a new mediator, someone or something that explains how primordial chaos turned into absolute order in record time. The reality is that the universe is more ambitious than our theories, and the matter that forms us has roots in a past that was much more dynamic and violent than we dared to imagine. The consolidation of this theoretical structure allows us finally to deliver the central piece of our modern understanding of the cosmos. Matter is not an accident, but the result of absolute mathematical refinement. The delivery here lies in the perception that every atom that composes our body and the stars we observe depends on a precarious balance of forces that became established in the first microseconds after the Big Bang. The Standard Model, in describing how fundamental particles interact with the Higgs field, offers a causal explanation for the existence of structure. Without this interaction, the universe would be an eternal ocean of radiation, where energy would never find rest to become mass. This thesis delivers to us a universe that makes sense, where the physics of the infinitely small dictates the rules of the game for the infinitely large, allowing science to predict with precision the behavior of matter from the laboratory to the most distant nebulae. The closing of this stage reinforces the idea that we live in a cosmos of progressive order. Particle physics and the symmetry-breaking mechanism establish a timetable of slow and safe evolution. We believe that once mass was conferred on particles, gravity assumed the role of architect, gathering hydrogen and helium into vast clouds that over hundreds of millions of years collapsed to form the first generations of stars. This hierarchical formation model is what sustains all 20th century cosmology. It suggests that the maturity of galaxies is a process that requires cosmic patience. The structures we see today are the product of a gradual accumulation, where each stage, from the creation of the atomic nucleus to the glow of supernova, followed a rhythm dictated by the density and temperature of space in expansion. As we seal this understanding, we realize that the thesis of particle physics gave us not just formulas, but a narrative of stability. The universe is seen as a mechanism where the pieces fit perfectly if we give them enough time. The success of the Standard Model in explaining the mass of quarks and the stability of the electron gives us confidence that the past of the universe is an open book, whose initial pages have already been deciphered. The logical closing of this view is that the origin of mass explains, consequently, the origin of everything that is solid and visible. We are delivering a map where physical reality is predictable, measurable, and above all logical. It is the celebration of the human mind that through particle accelerators managed to replicate and understand the secrets of the creation of primordial matter. However, this same closing carries with it the seed of a deep conflict. If the laws that govern mass and gravity are as constant and predictable as this thesis suggests, the pace of construction of the universe should be equally predictable. We are closing this phase with the conviction that the universe grew according to the rules of a slow cooling. But it is precisely here that the perfection of theory begins to feel the pressure of observed reality. By accepting that ordinary matter and the Higgs field are the only engines of mass, we are also accepting a speed limit for history. The closing of this point of view leaves us behind a wall. If the universe respects this timetable, why do the images we are receiving from the remote past seem to show a scenario much more advanced and complex than our thesis allows? This final delivery of the thesis places us in a state of intellectual readiness. We explained how mass arises and how gravity organizes that mass into larger systems, but we did so within a model that assumes linear evolution. The success of this cycle of thought lies in its ability to unify the micro and the macro under a single mathematical language. However, the price of that unification is the need for observational data to confirm the slowness of the process. What has been delivered so far is the best that human reason has produced to avoid mystery. It is the attempt to reduce the miracle of creation to a succession of predictable quantum events. We conclude this reasoning with a theoretical structure, unshakable in our laboratories, but that begins to tremble when we point our eyes to the horizon of time. The thesis of particle physics and gradual evolution provided the foundation for everything we thought we knew about the origins and workings of the universe. But the history of science teaches us that whenever a model reaches its maximum perfection, an observation arises that challenges it. The stage is set, matter gained its weight, the laws were established, and the universe began its journey. What we will see next is not just a new image, but the confrontation between the security of this theoretical closing and the brutality of a cosmos that insists on being much faster than our logic allows. The silence that follows this understanding is the prelude to the fall of certainties, where the elegance of quarks will have to explain itself before the impossible vision of galaxies that were born before time. The model of mathematical perfection that science built over decades, sustained by particle physics and the idea of a slow evolution of matter, has just collided with an incontestable photographic reality that challenges our fundamental understanding of the origin of everything that exists. For a long time, the human view of the beginning of time was protected by our own technical limitations. We had elegant theories and sophisticated computational models, but lacked direct visual evidence of the most remote eras. When the James Webb Space Telescope finally positioned its mirrors toward deep space, it did not merely capture the light of distant objects, but recorded an anomaly that threatens to disintegrate the cosmic chronology we accepted as absolute truth. What the infrared sensors revealed was the presence of massive, organized and chemically rich structures existing in a period where, according to all calculations of thermodynamics and gravity, there should be only a chaotic fog of hydrogen and helium. This is the fundamental contradiction that now paralyzes cosmology. Direct observation is denying the theoretical progression we considered the pillar of our intelligence. To understand the gravity of this conflict, one must look at the raw data that now redefine the frontiers of knowledge. In points of the sky that seemed empty to previous instruments, the new observer revealed complex systems that shine with the intensity of hundreds of billions of stars. Gravity seems to have operated in a miraculous and inexplicable way. According to the cosmological concordance model, galaxies need temporal windows of billions of years to accumulate sufficient mass and become structured spirals or ellipticals. Yet we are observing objects that had already reached full maturity when the system was less than 5% of its current age. It is an unprecedented temporal paradox. Theory establishes that such formations are physically impossible at that time, but visual evidence confirms their presence, requiring science to choose between its mathematical models and observed reality. This premature presence of order challenges our understanding of how the fundamental components clustered after the initial inflation phase. If ordinary matter is the only one responsible for forming these celestial bodies, the rate of conversion of gas into stars would have to have been orders of magnitude faster than any physical process we observe anywhere else. What the images show is that the dawn of time was not a slow and gradual awakening, but an explosion of frenetic, extremely efficient, and coordinated activity. Galaxies situated at the confines of the fossil record became the greatest challenge for theorists, for they present a chemical richness that suggests that entire generations of suns had already been born, lived, and died before the environment had even had time to cool adequately. Where predictions indicated seeds of galaxies, we found fully developed ancestral systems with defined spiral arms and dense cores that should not be there. The discrepancy deepens when we analyze the dynamics of spacetime itself. It is not just that objects are too large or appeared too early, it is a rhythmic mismatch in expansion itself. The measurements obtained through the cosmic microwave background, the remnant echo of the first moment, do not coincide with the measurements we obtain when observing individual stars in distant systems. There is a flaw in our measuring ruler. Space seems to be expanding in a way that suggests our understanding of dark energy is incomplete, or that the laws that govern matter undergo mutations as we go back through the millennia. The instrument did not bring the comfort of confirmation that many expected. It brought the proof that we inhabit a system that refuses to be dominated by linear growth models. What is now called impossible galaxies represents the cry of reality against the dogma of theory. If the hierarchical formation model were correct, the young universe should be populated by small galactic dwarfs, disorganized fragments that slowly merged over eras. Instead, we find monsters that rival the Milky Way in stellar density, more compressed in much smaller spaces. The physics that governs the collapse of gas clouds seems to have worked in a regime of extreme acceleration, which raises questions about the role of dark matter or forces still unknown that may have acted as catalysts. The telescope is not just discovering new celestial bodies, it is deconstructing our certainty about how time flows and how structure solidifies on large scales. This impact strikes at the core of scientific identity and the intellectual security of our species. We design machines with the expectation of validating accumulated knowledge, but the true function of technology has revealed itself to be the exposure of our ignorance. The light that is captured, shifted to the infrared spectrum by expansion, functions as a historical record that returns to us the failure of our most sophisticated simulations. When we translate this data, we do not just see distant colors and shapes. We see the urgent need for a new interpretation that can reconcile the thesis of fundamental particles with this new reality. The veil of theoretical arrogance has been torn, leaving us exposed to a scenario much older, denser, and more sophisticated than any project we have designed before. We are now in a territory of paradigm crisis where direct observation forces us to consider whether our interpretation of general relativity on macroscopic scales needs drastic adjustments. Perhaps the influence of mass is not the constant force we imagine at distances of billions of light-years, or perhaps the energy that drives the void possesses properties that allow the creation of solid structures almost instantly. What remains undeniable is that the historical record, now revealed with disturbing clarity, does not match the narrative we have been teaching. The conflict is established. The standard model states that these objects should not exist, while the data show that they are the basis of reality. This is the moment when investigation is forced to abandon the comfort of the known, to embrace the perplexity of a universe that is in every sense inexplicable under the old rules. The complexity of these remote systems indicates that the process of nucleosynthesis and the formation of supermassive black holes occurred in a symbiosis that our science still cannot replicate. Each new measurement of mass and brightness adds more pressure on the equations that sustain modern cosmology. If a galaxy can reach a state of maturity in only a few 100 million years, our definition of cosmic time needs a radical revision. We are not just looking at the past, we are looking at a version of physics that operated under conditions of density and temperature that turned the improbable into the inevitable. The conclusion of this moment of discovery is that the simplicity we attributed to the beginning of time was only an illusion caused by limited instruments, and what the present shows us is an impatient cosmos that did not wait for theoretical authorization to become majestic and complex. The discrepancy between what the equations predicted and what the infrared sensors captured reaches its most critical point when we analyze the so-called Hubble tension. This phenomenon is not just a statistical detail or a negligible margin of error. It represents a structural failure in our ability to measure the expansion of the universe and consequently to date its history. When we observe the remnant light of the first moment through the cosmic microwave background, the mathematical calculations suggest a specific recession speed for galaxies. However, when we use the telescope to measure the distance of individual stars and distant systems, the value obtained is significantly higher. There is a rhythmic mismatch at the heart of space. This difference implies that either our understanding of dark energy is fundamentally wrong, or gravity behaves in an exotic way on cosmic scales we have not yet been able to replicate. The conflict between the primordial echo and direct observations calls into question the integrity of our entire timeline, suggesting that the cosmos possesses layers of complexity that previous models simply cannot embrace. Deepening this contradiction requires looking at the metallicity of the first detected structures, According to particle physics and traditional nucleosynthesis models, the initial environment should have been composed almost exclusively of hydrogen and helium. Heavier elements such as oxygen, carbon, and iron, necessary to form solid planets and life itself, need temporal windows of billions of years to be forged in the interior of successive generations of stars. Yet what the new data reveal are systems that, scarce millions of years after the birth of time, already present a disconcerting chemical abundance. For these metals to exist so early, entire generations of massive suns would have had to be born, evolved, and explode in an interval that challenges any known simulation of stellar evolution. Matter seems to have been processed at a frenetic speed, indicating that the cosmic dawn was not a process of slow heating, but an explosion of chemical and structural activity that ignored the time restrictions we consider mandatory. The presence of supermassive black holes in these remote eras is the final blow to the idea of gradual and organic growth. It is physically impossible for a black hole with 1 billion solar masses to have formed from the collapse of a single star in the short time available from the initial event until the era when these giants are observed. The existence of these monsters at the beginning of history implies processes of direct collapse, where vast gas clouds condense without passing through the intermediate stellar phase, or that the density of the primitive environment allowed matter-feeding mechanisms that we do not see operating in the current universe. The image of a cosmos that organizes itself in linear and predictable stages is replaced by a reality of violent and instant collapses. We are observing a past where order arose from chaos, with an efficacy that our theories of gravity and radiation cannot justify, revealing that the engine of creation operated in a high-pressure regime that our science is only beginning to glimpse under the veil of uncertainty. With each new measurement, we realize that the road traveled by light is much longer and more complex than the map suggested. The observed galaxies are small, compact, and immensely bright, clustering a density of stars that rivals the centers of modern galaxies, but concentrated in a drastically smaller volume. This level of compression of matter suggests that the density fluctuations at the beginning of everything were much more extreme than predicted by the classical theory of inflation. What the telescope is doing is deconstructing our certainty about how time flows and how structure solidifies on large scales. The reality that emerges is that of an impatient system that did not wait for our laws of cooling and dispersion to become vast and complex. We are before the proof that we inhabit a cosmos that possesses secrets guarded in its own speed of expansion and in the premature maturity of its lights, forcing us to admit that the history of the beginning needs to be rewritten with an intellectual courage that the old view never dared to have. This premature maturity extends also to the morphology of galaxies. The first forms were expected to be irregular, shapeless clumps of gas and stars in collision, yet the observations reveal well-defined spiral disks and protogalaxies with internal structures that suggest a dynamic stability achieved in record time. This raises the question about the role of dark matter. If galaxies formed so fast and so early, perhaps dark matter is not just a passive component that provides extra gravity, but an active catalyst that shaped the universe much more aggressively than we supposed. The antithesis between the standard model and observed reality is not just a debate about numbers, but about the very nature of matter. If our understanding of fundamental particles tells us that mass arises from the Higgs field, the observation of the macro tells us that this mass organizes itself in patterns that challenge the chronology of that same physics. The volume of stars present in these ancestral galaxies also imposes a dilemma about the efficiency of stellar formation. In nearby galaxies, only a small fraction of the available gas is converted into stars every million years. The young universe recently revealed that efficiency would have to be almost 100%. This means that almost all the available hydrogen was transformed into stellar fire simultaneously and in a coordinated way. There is no parallel for this in modern physics. It is as if the primitive universe possessed an ignition trigger that was turned off as space expanded. What we see now is the residue of that violent process, a light that traveled for billions of years to tell us that the past was not a place of shadows and simplicity, but a scenario of blinding light and extreme complexity, where the laws of physics operate at their absolute limit of capacity. Confronted with this evidence, we are forced to reassess the concept of cosmic time. If atomic clocks and the laws of gravity are constant, then the history of the universe was much denser in events at its beginning than in any subsequent period. The thesis of slow and gradual evolution crumbles before the evidence of a cosmic childhood already adult. What we are witnessing is not a simple astronomical discovery, but a paradigm shift that affects our position in time. If galaxies could arise so fast, perhaps the universe is older than we think, or perhaps light has travel properties we do not yet understand. The investigation now enters a territory where the impossible is the only starting point, and the reconstruction of our narrative of origin requires that we accept that the universe is much stranger, faster, and more intelligent than our laboratory formulas were able to predict during the last century of science. Each pixel of information that descends from the servers of space agencies is a reminder that the past is a foreign territory where the logic that governs our solar system may be only a shadow of a much more powerful and unknown truth. As we close this analysis of the impossible maturity of galaxies, we realize that the simplicity we attributed to the Big Bang was only an illusion caused by limited instruments. What the present shows us is a cosmos that did not follow the script we wrote for it. Light tells a story of urgency, of direct collapses, and of a chemistry that flourished in the void long before any theory could imagine. We are on the threshold of a new understanding, where the thesis of particles and the antithesis of impossible galaxies will have to find common ground, so that the history of the universe can finally make sense under the gaze of the new astronomy. The conclusion that the visual evidence delivers is that the model of gradual evolution, until then considered the pillar of modern cosmology, was surpassed by direct observation. What the photographic record presents is the proof that matter possesses an intrinsic capacity for organization much more powerful and swift than laboratory simulations were able to predict. This stage of knowledge marks the definitive break of linearity. It is no longer possible to sustain the idea that the universe waited passively for gas to cool for countless eras, before only then beginning the construction of the great structures. On the contrary, the images reveal that massive galaxies arose as if the very fabric of space had been seeded with points of extreme density from the first instant, ignoring the slow processes of agglomeration that were once defended. Accepting this reality forces a reassessment of how primordial energy dissipated. Instead of a smooth and homogeneous dispersion, the data suggest processes of violent and immediate collapse that forged the architecture of deep time in an almost instant manner. When we look at these objects that theory classifies as impossible, we realize that gravity and light carry a message of urgency. The idea that we knew all the variables at the beginning of everything was disintegrated by current technological precision. This confrontation between mathematical prediction and observed fact is what defines the present state of an ignorance now illuminated by new data. The classical chronology is incomplete, and the mismatch between the speed of expansion and stellar maturity is not a calculation failure, but a symptom that cosmic dynamics possesses gears we have not yet been able to describe. The fossil record of deep space, in showing dense and chemically rich systems in such remote eras, acts as a severe judge over the theories of the last century. The model that explains with perfection the behavior of particles in controlled environments fails when trying to narrate the infancy of the cosmos. We are at a breaking point where the accumulation of anomalies has reached a critical mass that no longer allows superficial adjustments in the old equations. The system demands a reassessment of the foundations, for it is no longer possible to accommodate the existence of mature galaxies in a universe that should be only a soup of hydrogen. This phase of investigation has exposed the gaps in our understanding, leaving us in a state of necessary doubt, where the concrete data of the telescope is the only solid basis for what will follow. By recognizing that the theoretical map used for decades does not have the resolution to describe the captured reality, we open the way for a new interpretation. What has been demonstrated so far is the demolition of a certain intellectual arrogance before vastness. The territory we are photographing does not correspond to the sketch we drew on paper. Reality imposed itself on abstraction. The current challenge is to reconstruct a narrative that does justice to the speed and greatness of a system that reveals itself much older in its appearance and more sophisticated in its origin. The scenario is now clear of old dogmas, prepared for a search for unification that can reconcile the elegance of the atom with the inexplicable and magnificent brutality of the first lights that tear the darkness of the beginning. Everything that was observed points to a universe that did not follow the script of linear growth that human logic tries to impose on it. Light tells a story of creative impatience, of direct collapses, and of a chemistry that flourished in the void long before predicted. The imbalance between the thesis of stability and the reality of observation is the engine that pushes us toward a new understanding of existence. The maturity of these ancestral galaxies is the seal that closes our absolute confidence in the concordance model and forces us to look at the horizon of the visible with eyes that accept the raw complexity of the unknown. The history of the beginning of time is being rewritten now, not by theorists but by the universe itself, which through the infrared shows us that it was always much more than we were able to imagine. The reconciliation between the mathematical perfection of particle physics and the raw reality of impossible galaxies requires a deep reassessment of the standard cosmological model. The shock between the thesis of slow evolution and the antithesis of premature maturity finds its point of union in the hypothesis that dark matter and primordial energy are not static entities but dynamic and interactive from the first microseconds after the initial event. For the scenario observed by the infrared to make sense, science is beginning to draw a new narrative where the density fluctuations at the beginning of time were amplified by feedback processes we have not yet fully mapped. This synthesis does not discard what we know about fundamental components such as quarks and leptons, but suggests that the way they clustered on a large scale followed a script of acceleration that our laboratory physics, limited to comparative low energies, could not predict until now. The core of this new view lies in the idea that the seeds of galaxies did not arise only from random variations in the hydrogen soup, but from a pre-existing invisible architecture of dark matter that acted as a catalyst for direct collapse. If we accept that dark matter possesses self-interaction properties, or that it can interact with radiation in ways not predicted by classical general relativity, the formation of supermassive black holes and dense galaxies ceases to be a chronological miracle and becomes an inevitable consequence of high-energy physics. We are transitioning from a universe of organic growth to a universe of programmed structure, where chemical complexity and stellar organization are emergent properties of a system that was already born with the critical conditions for speed. The proposed synthesis unifies the precision of the atom with the speed of macroscopic structure, creating a model where time is not the only limiter, but rather the density of information and energy present in the primordial vacuum. For this unification to be solid, it is necessary to observe how the light of the first stars interacts with the intergalactic medium in a way that was previously ignored. The rionization of the universe, the period when the first light cleared the fog of neutral hydrogen, seems to have occurred in a much more fragmented and intense way than previous models suggest. The current synthesis proposes that the impossible galaxies were in fact the thermal engines that drove this transition, functioning as mass nuclear fusion laboratories that altered the cosmic environment on timescales without precedent. When we reconcile the data, we realize that particle physics provides the ingredients, but the dynamics of deep space provides the recipe for a chain reaction that turns the void into complexity. What we once saw as a contradiction is now interpreted as the workings of a cosmic machine that operates on multiple levels of speed, where matter organizes in millennia what we once thought would take eras. The reconciliation also reaches our understanding of inflation. If the universe expanded so rapidly and generated such mature structures, the irregularities in the energy field that drove that expansion must have been much more pronounced than the cosmic microwave background led us to believe. The synthesis requires that we integrate quantum field theory with the mechanics of galactic fluids, suggesting that what we call anomalies are in fact the rule of a system that does not seek equilibrium but maximum efficiency in the conversion of energy into organized mass. This new perspective allows particle physics to continue to be the basis of everything, while long-range astronomy becomes the final test for the laws of gravity in regimes that humanity had never before been able to observe. We are building a bridge between the infinitely small and the immensely vast, where the speed of creation is the missing link that finally unites what we know with what we are seeing. In this new paradigm, cosmic time ceases to be a linear corridor and becomes a field of variable densities. Galaxies are no longer seen as objects that compete against the clock to grow, but as natural manifestations of a space that possesses an inherent tendency toward the crystallization of structures. The synthesis proposed by the new astronomy tells us that premature maturity is not a flaw in history, but a chapter we had not yet read. By accepting that ordinary matter and dark matter work in a high-speed symbiosis, we eliminate the paradox of impossible galaxies. They become possible within a model that recognizes the power of primordial forces. This is the unification that science pursues, a theory where the simplicity of elementary particles and the majesty of galactic systems coexist without contradictions, revealing a universe that is in every detail a work of physical engineering of overwhelming precision and speed. The integration of these concepts also forces us to look at dark energy in a new light. If the expansion of the universe is not the constant and passive force we imagined, but something that possesses fluctuations and local variations at the beginning of history, then the ruler with which we measure deep time needs dynamic calibration. The synthesis suggests that the young universe was an environment of pressures and tensions that allowed the formation of gravitational wells much deeper than those observed today. This would explain why galaxies could accumulate so much mass in so little time. They were falling into density abysses that current expansion has already smoothed. This unification of ideas allows modern physics to maintain its integrity while adapting to a reality that is much more vibrant and energetic than predicted. What emerges is a cosmos that is not just a stage for matter, but an active participant in its own structuring. When we unite the thesis and the antithesis, we realize that the reality observed by James Webb is not the end of physics, but the beginning of a much richer understanding. The synthesis delivers to us a universe where complexity is the norm and speed is the method. There is no longer conflict between the atom and the galaxy, for both follow the same principle of accelerated organization. Chemical maturity, supermassive black holes, and extreme stellar density cease to be enigmas to become the pillars of a new chronology. We are living the moment when science ceases to look at the past as a shadow of simplicity and begins to see it as the peak of a creative activity that defines everything we are and everything we can observe. The final synthesis is the acceptance that we inhabit a system that possesses a structural intelligence that surpasses our capacity for simulation, but that now finally begins to be captured by our capacity for observation. This final reconciliation places the human being in a position of observer of a process that is both mathematical and monumental. The laws of physics have not changed, but our perception of how they manifest at the beginning of time was expanded to accommodate the greatness of what was discovered. The impossible universe became the real universe, and science, in embracing this synthesis, ensures that the search for truth continues to be guided not by established dogmas, but by the light that travels through the millennia to tell us the true story of who we are and where we came from. The unification is complete in the sense that we now possess a framework that, although complex, is coherent with the totality of the data. The cosmic dawn was in every sense a spectacle of instant maturity that the current synthesis finally allows us to admire without the weight of doubt. The technical reconciliation between the perfection of the atom and the magnitude of impossible galaxies requires a new mechanics of collapse. The traditional model that predicted a slow and laborious agglutination of gases is replaced by a synthesis of high structural and chemical performance. If particle physics provides the fundamental components of the cosmos, the dynamics observed at the confines of time reveal how those ingredients were organized under extreme pressures. The seeds of the great galaxies did not arise from random variations, but from an invisible architecture of dark matter that functioned as a catalyst for direct and immediate collapse. We are before a system that did not wait for passive cooling, but used the density of the primordial vacuum to crystallize complex structures in fractions of the time previously estimated by classical science. The deepening of this view reveals that the interaction between baryonic matter and dark matter was much more aggressive and symbiotic at the beginning. For mature galaxies to exist so early, it is necessary that gas fell into gravitational wells with a speed that ignored conventional hydrodynamic barriers. This cold feeding process allowed dense galactic centers and supermassive black holes to arise almost simultaneously with the ignition of the first stars, creating a scenario of sudden complexity. The physics that governs the behavior of plasma under these conditions of extreme proximity is the missing link that unites the mathematical thesis to the visual antithesis of James Webb. The young universe operated under a logic of absolute efficiency, where gravity and radiation found a dynamic balance that favored macroscopic construction in millennia, not in eras. The chemical maturity observed in these ancestral systems is the final testimony of a stellar life cycle that operated at very accelerated frequencies. If the first stars were massive, their deaths as supernovae occurred rapidly, seeding space with heavy elements such as iron and oxygen almost instantly on the cosmic clock. This accelerated enrichment allowed subsequent generations of stars to possess the fuel necessary to shine with the intensity of already evolved systems. The metallicity paradox is resolved when we accept that high-energy physics allows a recycling of matter that our current era cannot replicate. The cosmic dawn was not a process of slow heating, but an explosion of chemical activity that defined the architecture of deep time in a definitive and technically impeccable way. This dynamic of speed extends to the morphology of structures where well-defined spiral disks appear where there should only be shapeless gas clouds. The synthesis requires that we integrate quantum field theory with fluid mechanics on galactic scales, suggesting that what we call anomalies are the rules of a system that optimizes the conversion of energy. The light of the first stars functioned as a tool of thermal organization, clearing the fog of hydrogen and stabilizing systems in record time. When we reconcile the data, we realize that the observed reality is the final test for the laws of gravity in extreme regimes. We are building a bridge between the infinitely small and the immensely vast, where the speed of creation is the factor that finally unites what we know mathematically with what we are seeing photographically. Confronted with the evidence of a cosmic childhood already adult, we are forced to admit that time possesses variable densities of events. The thesis of gradual evolution crumbles before the synthesis of accelerated formation, revealing a cosmos that possesses an inherent tendency toward the crystallization of solid structures. The investigation enters a territory where the reality imposed by the telescope is the only starting point for the reconstruction of our narrative of origin. The impossible universe became the real universe, and science now seeks an understanding vast enough to contain the speed and greatness of a system that never knew how to be simple. The dawn was a spectacle of maturity that the new physics finally allows us to quantify, revealing that the history of the beginning is a work of physical engineering of absolute precision. The efficiency of the initial process raises fundamental questions about the very nature of the vacuum and the energy that composes it. If space possesses an intrinsic energy that drives expansion, that same energy may have served as the conductor that allowed the dissipation of the heat necessary for immediate stellar collapse. This harmony between destruction and creation is what turned the void into a place of light in record time, defeating entropy through an unprecedented structural acceleration. The speed with which chemistry diversified is the seal of a physical plan that prioritizes organization and complexity over chaos. What we see today in the fossil record of deep space is the result of an initial race where matter organized itself with a structural intelligence that surpasses any simulation, proving that the past was the peak of creative activity. When we look at these remote objects, we perceive that the road traveled by light is much more complex than the theoretical maps suggested before. The ancestral galaxies, small and immensely bright, concentrate a density of stars that challenges the limits of compression of matter known in modern physics. This level of organization suggests that the density fluctuations at the beginning of everything were much more extreme and coordinated than classical theory allowed us to imagine. The telescope deconstructs our certainty about the linear flow of time, forcing us to accept that the system did not wait for our laws of cooling to become vast. The reality that emerges is that of an impatient and capable cosmos that used every gram of primordial energy to solidify its presence in the void in a magnificent and irreversible way under the gaze of the new astronomy. The final reconciliation places the atom and the galaxy under the same principle of accelerated operation, eliminating the friction between theory and observational practice. There is no longer an abyss between what mathematics predicts for the micro and what the image shows for the macro. For both are faces of the same coin of cosmic efficiency. Chemical maturity, supermassive black holes, and extreme stellar density cease to be enigmas to become the pillars of a revised and robust chronology. We are living the moment when science ceases to look at the past as a shadow of simplicity and begins to understand it as the high-performance laboratory that defined everything that exists. The synthesis is the acceptance that we inhabit a system of surgical precision, where the speed of creation is the greatest evidence that the structure of the universe was planned by its own fundamental laws. At this new stage of knowledge, the silence that preceded the final revelation is filled by the clarity of the data that travel through the millennia. Light does not just bring us images, but brings us proof that the history of the universe needs to be read with the courage of those who accept the raw complexity of the unknown. The unification is complete in the sense that we now possess a framework that, although vast and swift, is coherent with the totality of particles and stars. The real universe surpassed the limited theory and science in embracing this synthesis of deepening and ensured that the search for truth was guided by the observation of a dawn that was a spectacle of instant maturity and overwhelming physical power. The challenge now is to map the invisible connections that sustain these cathedrals of light at the beginning of time. If each mature galaxy is a node in a web of dark matter, the web itself must have formed with a geometric precision that our physics is still trying to fully encode. Space is not a sterile void, but a fertile medium where matter behaves like an intelligent fluid, finding the paths of least resistance to reach the state of maximum organization under extreme conditions of density. The synthesis proposed in this cycle of knowledge is not just a course correction, but an expansion of scientific consciousness about the fundamental nature of physical reality. We are learning that the cosmos is not just a place where things happen, but an entity that manifests itself through the very structure of matter, revealing its complexity with a hurry that challenges our linear perception. The cosmic dawn was the moment when infinity became geometry and science, in refining its gaze through these new infrared discoveries that prepared itself for the next leap of understanding about what the beginning really means. At the end of this dive into the depths, the image that remains is that of a universe that never knew hesitation or delay. From the first microsecond to the formation of the galaxies, we now observe the narrative is one of relentless precision and absolute energetic efficacy. Particle physics and large-scale cosmology finally speak the same language, the language of optimization. What James Webb delivered to us was not a crisis but an invitation to abandon the view of slow organic growth and embrace the simultaneity of greatness. The silence that once surrounded the Big Bang was replaced by the noise of a creation that still echoes in every spectrum of light, reminding us that the impossible is only what our incomplete theories did not yet have the courage to predict as a consummate fact of nature. The final resolution of this conversation does not lie in the denial of previous mathematical models, but in the acceptance that the structure of the universe possesses an efficiency of execution that our classical physics has only begun to scratch. The paradox of impossible galaxies is dissolved when we understand that the cosmic dawn was not a process of chemical trial and error, but a direct manifestation of an order that was already encoded in the quantum fluctuations of the primordial vacuum. The definitive delivery of this cycle of understanding is the perception that matter and energy worked in a high-speed symbiosis, where every fundamental particle found its place in a macroscopic architecture with a precision that ignores our estimates of linear time. What James Webb reveals to us is a cosmos that did not need eras to mature because its maturity was an emergent and immediate property of inflation itself. This closing reconciles the thesis of subatomic perfection with the antithesis of infrared observation, creating a framework where deep time is redefined by the density of events and not just by the passage of millennia. Science now possesses the tools to observe the gear in operation, proving that the improbability was in fact the original plan of a system that optimizes complexity on all scales. As we tie this content together, we realize that the unification is complete. The atom and the galaxy are expressions of the same law of structural acceleration that governs the beginning of everything. The silence that once surrounded the origins is filled by the infrared light that tells us a story of absolute efficacy, ensuring that our search for truth continues to be guided by the evidence of a universe that is in every detail a work of physical engineering, of overwhelming speed and technically impeccable. The logical tying of this cycle reconnects us to the initial moment where doubt about the standard model arose, transforming that uncertainty into the basis of a much more robust new chronology. The closing of this loop initiated in the first cycle allows the observer to understand that the conflict between theory and reality was the necessary engine for the expansion of human knowledge about space and time. The galaxies that should not be there are now the pillars of our new theoretical home, serving as beacons that illuminate the path to the next frontier of discovery. The real universe surpassed the fiction of our technical limitations, revealing a past that was the peak of creative and structural activity. The final synthesis is the acceptance that the cosmos is a vibrant entity that uses gravity and light to write its own biography with a hurry that we have only now begun to admire with due scientific clarity. With the integration of these concepts, the script of creation reaches its point of balance, where the mathematics of particles and the vision of telescopes cease to be adversaries to become allies in the description of a magnificent dawn. The history of the universe ceases to be a succession of accidents and comes to be understood as a sequence of high energetic performance events that shape the destiny of everything we observe today. Chemical complexity and the organization of stars are the signatures of a system that never knew how to be simple or slow, but that always prioritized excellence in the construction of physical reality. As we close this phase of the synthesis, we prepare the ground for the final conclusion, where the emotional impact of belonging to such a precise and swift system will be explored in all its metaphysical and scientific greatness. The transition to the final conclusion requires that we take with us the certainty that the light that traveled through the millennia did not lie. It only waited for us to have the right technology to read its message of instant maturity. The paradox was our gateway to a greater truth about the nature of space and the laws that govern it under conditions of extreme density. What we once saw as a flaw in the narrative was in fact the most important chapter of the story, the one where the universe proves that it is capable of skipping stages to reach sophistication. The unification of the data allows us now to look at the abyss of time with the confidence of those who deciphered the algorithm of rapid creation, transforming the mystery of ancestral galaxies into the greatest proof of the elegance and power that reside at the center of every atom and every galaxy that populates the immense void. The silence that precedes the final and absolute revelation is the necessary breath before we face the last gap of understanding, the relationship between the consciousness that is observed and the cosmos that is observed. If the universe organized itself with such speed to allow mature structures to arise so early, what is the role of human observation in this process of cosmic self-discovery? The synthesis delivered in this cycle prepares the scientific spirit for the emotional catharsis that will follow, where logic and feeling will merge in the understanding that we are the universe trying to understand its own beginning. The speed of primordial creation is the mirror of our own urgency to understand our origin and our place in the vast ocean of stars. The dawn was fast, it was intense, and it was perfect. And now with the complete synthesis, we are ready for the final word that will reconcile all remaining paradoxes in our journey of discovery. The universe operates under a logic of precision that challenges our common perception of the passage of the ages. The final reconciliation of this understanding does not lie in the denial of the mathematical models we built, but in the acceptance that the structure of the cosmos possesses an efficiency of execution that our classical physics has only begun to map with clarity. The enigma of the galaxies that arose with premature maturity is dissolved when we understand that the dawn of time was not a process of trial and error, but a direct manifestation of an order already encoded in the primordial fluctuations. The definitive perception is that matter and energy worked in a high-speed symbiosis, where every fundamental component found its place in a vast architecture with a precision that ignores estimates of linear progress. What the new data reveal is a scenario that did not need millennia to mature because its complexity was an inherent and immediate property of the original expansion itself. This unified view harmonizes the behavior of the subatomic world with the reality of large-scale observations, creating a framework where time is defined by the density of events and not just by the flow of the centuries. The structural intelligence of the system proves that the improbability was in fact the inevitable consequence of a mechanism that optimizes organization in all dimensions. As we integrate this knowledge, we realize that the unification is full. The particle and the galaxy are expressions of the same law of acceleration that governs existence from the first moment. The silence about the origins gives way to a narrative of absolute efficacy, ensuring that knowledge continues to be guided by the evidence of a physical reality of overwhelming speed and technically impeccable. The logical tying of this thought reconnects the observer to the point where the initial doubt arose, transforming the uncertainty into the basis of a much more robust understanding of the formation of everything we see. The closing of this flow of ideas allows us to understand that the shock between what we predicted and what we observed was the necessary engine for the expansion of consciousness about the nature of space. The formations that seemed impossible are now the pillars of a new foundation, serving as references that illuminate the path to the next discoveries. Reality surpassed the limitations of our old tools, revealing a past that was the peak of the creative and structural activity of the cosmos. It is the acceptance that we inhabit a vibrant system that uses gravity and radiation to establish its own history with a hurry that we have only now begun to admire. With the integration of these concepts, the description of the emergence of things reaches its point of balance where the mathematics of fundamental forces and the vision of modern telescopes cease to be divergent to become allies. The trajectory of the cosmos ceases to be seen as a succession of gradual accidents and comes to be understood as a sequence of high-performance events that shaped the destiny of every star. Chemical organization and the stability of systems are the signatures of a system that never operated slowly, but that always prioritized excellence in the construction of physical reality. As we consolidate this understanding, we prepare the ground for the final perception, where the impact of belonging to such a precise mechanism will be explored in all its greatness and depth. Full understanding requires the certainty that the light that traveled across immense distances brought with it a message of instant maturity that cannot be ignored. What seemed a paradox was the gateway to a greater truth about the nature of the void and the laws that govern it under extreme conditions. What was once read as an anomaly in history was the central point, the moment when the universe proved capable of skipping stages to reach structural sophistication. The unification of the data allows us to look at vastness with the confidence of those who deciphered a process of rapid creation, transforming the mystery of ancestral lights into the greatest proof of the elegance that resides at the center of every atom and every cluster that populates space. The silence that precedes total understanding is the necessary breath before we face the relationship between the consciousness that we observe and the reality that is observed. If the universe organized itself with such speed to allow mature systems to arise so early, what is the role of the human observer in this journey of self-discovery? The knowledge delivered so far prepares the way for a perception where logic and feeling merge in the understanding that we are the very matter trying to understand its own origin. The speed of primordial structuring is the reflection of our urgency to understand our place in the ocean of stars. The dawn was intense and perfect, and now the final word will reconcile the remaining doubts in our search for the absolute truth about who we are and where we came from. The dive into the depths of cosmic organization reveals that the speed in the formation of the first galaxies was not just an isolated event, but the necessary foundation for the chemical stability that allowed the existence of complex planetary systems. When we observe the maturity of these ancestral structures, we perceive that the efficiency with which gas was converted into massive stars functioned as a thermal and chemical engine of monumental proportions. These first generations of stars, enclosing their cycles in violent and coordinated explosions, seeded space with the heavy elements indispensable for the construction of matter as we know it today. If the universe had followed the slow rhythm predicted by the old theories, the dispersion of these metals would have occurred in a much more diluted way, possibly delaying the formation of rocky worlds by billions of years on the clock of existence. The speed of creation is therefore not a mere chronological detail, but an essential condition for life to find firm ground to flourish. The dynamics of this deepening show us that the physical intelligence of the system resides in its capacity to concentrate energy at critical points of density from the first moments. Dark matter did not act only as a static scaffold, but as a dynamic accelerator that forced hydrogen to reach states of extreme compression in time intervals that challenge classical intuition. This direct and orchestrated collapse allowed massive black holes to emerge as the gravitational anchors of vast stellar metropolises, stabilizing orbits and ensuring that the flow of energy was constant and productive. We are before a reality where the speed of creation was the determining factor for the preservation of order, preventing entropy from fragmenting the cosmos into a fog of inert gas without structural purpose. Each deep gravitational well served as a high-pressure laboratory where reality was forged with a hurry that reveals the urgency of fundamental forces to manifest complexity. When we analyze the metallicity of these distant objects, the evidence of a vibrant past becomes irrefutable for any rigorous technical observation. The presence of complex elements in galaxies that existed only a few 100 million years ago proves that the stellar life cycle was compressed by pressures and temperatures that our current cosmic neighborhood can no longer replicate. This high-performance phase was the definitive laboratory of physics, where the fundamental laws were tested to the limit to generate the atomic diversity that composes every fiber of observable reality. The young universe was an environment of rapid transformations, where light and mass danced at a frequency much higher than we are accustomed to, revealing an intrinsic urgency in the structuring of everything that is vast and complex. What we see now through the infrared gaze is the fossil record of a golden age, where matter learned to organize itself with absolute mastery. This dynamic of speed extends to the very geometry of galaxies, which exhibit symmetries and disk structures in eras when theory predicted only primordial chaos. The integration between intense radiation and sovereign gravity created a feedback mechanism that cleared the intergalactic medium, allowing light to travel across immense distances without being absorbed by opaque clouds of neutral hydrogen. This process of reionization, fueled by the veracity of the first stars, was the event that finally made the universe transparent, marking the victory of organization over primordial darkness. The clarity that James Webb delivers to us now is the direct result of that thermal clearing, allowing us to look back and see physical engineering in its purest and most functional state. The transparency of the cosmos was not a gift of time, but a conquest of light in its battle against the opacity of hydrogen. The understanding of this deepening forces us to reconsider the relationship between the scale of time and the scale of complexity in all its manifestations. If macroscopic structure was established with such readiness, the seed of life and consciousness may be much more deeply rooted in the original mechanics than we dared to suppose before. The cosmos did not wait for chance. It followed a trajectory of maximum energetic efficiency to ensure that the critical conditions of stability were reached as quickly as possible. Each mature galaxy on the infrared horizon is a testimony that order is not a late accident, but a fundamental priority of a system that operates with surgical precision in all its dimensions and scales. The readiness of matter to cluster suggests that the universe possesses an accelerated growth plan that we are finally beginning to read with clarity. We take this understanding to the frontier, where technical observation dissolves into the perception of a coherent and magnificent whole. The lesson that the impossible galaxies leave us is that our ruler for measuring the progress of the universe needed an immediate dynamic recalibration. By accepting that speed is the trademark of structural creation, we eliminate the gaps between what we calculate and what we see, uniting the destiny of elementary particles to the destiny of the greatest cathedrals of light. The real universe is much more vibrant, swift and capable than any fiction, and its history is an account of constant overcoming of the barriers of entropy through a physical engineering that does not know hesitation. We are inhabiting a system that does not know delay, where beauty and function are inseparable properties of a space that was born to be complex. To ground this new view, we need to look at the density fluctuations at the beginning of everything as the source code of an accelerated reality. If the fabric of space-time was stretched violently during inflation, the resulting irregularities were the seeds of a magnificent harvest of stars and planets. The symmetry we observe today is the result of a balanced battle between the expansive force of dark energy and the agglutinating force of gravity, where the second prevailed in the first moments to ensure the foundation of galaxies. There was no period of absolute silence, but rather a symphony of collisions and mergers that forged the backbone of the cosmos. The timescale that once seemed insufficient now reveals itself as the perfect interval for a system that operates with maximum economy of motion and maximum structural result. Premature stellar maturity also implies that the chemical evolution of the universe was not a slow step, but a monumental leap toward diversity. When heavy elements are forged in the heart of the first giants, they are expelled into the intergalactic medium with a speed that allows the formation of solar generations much richer and more stable. This means that the conditions for habitability may have arisen in time windows we once considered impossible, radically changing our search for biological origins in the vast stellar ocean. The universe in its majestic hurry prepared the stage for life long before our linear models dared to predict, proving that complexity is a physical imperative from the first microsecond. When we contemplate the infrared images, we perceive that we are looking at the apex of an engineering process that does not admit failure. Each glow that reaches us from a remote galaxy is the confirmation that the laws of physics are universal and timeless, but that their manifestation can be much more vigorous than we imagined. The resistance of matter to remain dispersed was overcome by the irresistible attraction of order, creating structures that serve as anchors for reality, in a void that without them would be devoid of meaning. The speed of structuring is the greatest proof that the universe possesses an inherent tendency toward the crystallization of organized systems, acting like a living organism that seeks its definitive form with unshakable determination. At this stage of knowledge, the frontier between theory and observation ceases to exist, giving way to an integrated understanding that embraces speed as a fundamental value. The unification of forces at the beginning of time provided the necessary impulse for the cosmos to leap from atomic simplicity to galactic complexity in an astronomical blink of an eye. This revelation forces us to look at the future with the same lens of acceleration, recognizing that evolution did not stop but continues to unfold on scales of complexity we are still trying to decipher. The cosmic dawn was only the prologue of a story of absolute efficiency that is still being written in every corner of space, where light continues to travel to tell us that the impossible has already happened and continues to happen. The stability we enjoy today in our own galaxy is the direct heir of that primordial creative fury. Stable orbits, the rich composition of the Earth and the balanced radiation of our Sun are byproducts of an era when physics operated in regimes of creative high voltage. When we understand the deepening of this process, we perceive that we are not a late accident in a cold universe, but the planned result of a system that optimizes every particle of energy to generate organized mass. The speed of creation is the seal of authenticity of a cosmos that functions with surgical precision, turning the void into a place of light, color, and structure, with a mastery that challenges any human attempt at perfect simulation. The final unification of this thought takes us to a state of technical admiration, where the greatness of what we observe is proportional to the clarity of the laws that govern it. The real universe surpassed the fiction of our initial ignorance, revealing itself as a mechanism of incalculable beauty and power. The dawn was fast, it was intense, and it was perfect, leaving behind a record that we now finally have the courage and technology to read. The history of the beginning is an account of the victory of light over darkness, of order over chaos, and of complexity over simplicity, proving that we inhabit a work of physical art that was executed with magnificent hurry to ensure that infinity had finally a form to be admired by those who have the courage to look at the depths of time. The final resolution of the trajectory we have traveled lies in the perception that the universe is not just a place where things happen, but an entity that manifests itself through absolute efficiency. The reconciliation between what we calculate and what the telescopes show us now is proof that physical reality possesses a capacity for organization that ignores our limitations of time. The galaxies we observe in the depths of space are not anomalies that break the laws of nature, but the testimony of a system that reached maturity with magnificent and necessary hurry. The cosmic dawn was the moment when raw energy was transformed into complex structure, revealing that order was encoded in every primordial fluctuation from the first microsecond of the initial expansion. We are now delivering the understanding that the cosmos operated at high performance to ensure that the architecture of light and matter was established without any hesitation or delay on the clock of eternity. This definitive delivery forces us to abandon the idea of slow and laborious growth in favor of a view where complexity is an immediate and direct imperative of the vacuum. If the seed of chemical and structural maturity was planted so early, the development of everything we know is the natural unfolding of a physical plan that prioritizes stability. The intelligence of the system manifests itself in the way gravity and radiation found a dynamic balance, allowing cathedrals of stars to arise where we once predicted only void. The closing of this narrative occurs when we realize that the real universe is much more capable and swift than our incomplete theories dared to suggest in times of limited observation. The light that traveled through the millennia brought the message that the history of the beginning is in every detail a work of physical engineering, executed with surgical precision and overwhelming power. As we tie all the concepts together, we realize that the paradox of accelerated formation is the key to understanding our own position in this vast ocean of galaxies and mysteries. The unification of fundamental forces provided the impulse that transformed atomic simplicity into macroscopic greatness in a time interval we now recognize as perfect for life. The speed of creation was not an accident, but the seal of authenticity of a cosmos that functions with an economy of motion and a structural result without precedent in nature. The closing of this cycle of discovery leaves us with the certainty that beauty and function are inseparable properties of a space that was born to harbor maximum complexity. We are before a system that does not know error, where every dense galaxy and every supermassive black hole at the dawn of time are the pillars of a solid reality. The impact of this revelation forever alters our perception of the chemical and biological evolution that allowed the existence of a consciousness capable of observing such distant phenomena. If the conditions for planetary habitability were established in much smaller time windows, the possibility of order and life becomes an omnipresent trait in the very structure of original spacetime. The universe, in its majestic hurry, prepared the stage for diversity long before our linear models were able to predict with technical and scientific safety. The final lesson of the impossible galaxies is that the impossible has already happened and continues to shape the destiny of every particle that composes the fabric of our current and future existence. The history of the universe is an account of the victory of light over opacity, proving that complexity is the final goal of a system that never knew how to be simple. In this closing, the frontier between the observer and the observed dissolves into an integrated understanding that we are the result of a creative fury that does not admit delays. The transparency of the cosmos, the richness of chemical elements, and the stability of orbits are the direct heirs of a golden age when physics operated at the limit. When we look at the infrared horizon, we do not just see remote light, but the reflection of a mechanism that optimizes every fraction of energy to generate organized mass with mastery. The absolute delivery of this knowledge is the acceptance that we inhabit a work of physical art that was executed with unshakable determination to ensure the triumph of light. The dawn was fast, intense, and technically impeccable, leaving behind a record that we now have the courage and technology necessary to read and finally understand in depth. The silence that once surrounded the beginning of everything was replaced by the clarity of a symphony of events that echo in every spectrum of radiation that reaches our modern detectors. The unification is complete because we now possess a framework that, although vast and swift, is coherent with the totality of elementary particles and the immense galactic structures observed. The real universe surpassed theory, and science ensures that the search for truth will continue to be illuminated by the certainty that the cosmos is a place of order. The trajectory of creation ends where our admiration begins, at the exact point where we realize that speed was the tool used to build eternity in fractions of a second. The closing is the peace of those who understand that the system is perfect and that its history is the greatest proof of a physical power that knows no limits. The efficacy of the initial process raises the definitive questions about the nature of the vacuum and the energy that composes it on scales that challenge our purely human and limited imagination. If space possesses an intrinsic energy, that same force serves as the conductor that allows the dissipation of the heat necessary for immediate and efficient stellar collapse at the origin. This harmony between the destruction of simple forms and the creation of complex structures turned the void into a place of light in record time on the clock of absolute physical nature. The speed with which chemistry diversified is the seal of a physical plan that prioritizes organization and complexity over chaos in any circumstance or observed stellar era. What we see today in the fossil record of deep space is the result of an initial race where matter organized itself with an intelligence that surpasses any computer simulation. When we look at these remote objects, we perceive that the road traveled by light is the conducting thread that unites our present to the moment when everything begins to shine. The ancestral galaxies concentrate a density of stars that challenges the limits of compression of matter known in modern physics. Suggesting that order is an absolute and constant physical imperative, the telescope deconstructed our certainty about the linear flow of time, forcing the acceptance that the system did not wait for our laws of slow cooling to become vast. The reality that emerges is that of an impatient and capable cosmos that used every gram of primordial energy to solidify its magnificent presence under the gaze of the new infrared astronomy. The final reconciliation places the atom and the galaxy under the same principle of accelerated operation, eliminating the friction between mathematical theory and visual and scientific practice. In this conclusion, the mystery of the galaxies that should not be there becomes the solid basis of a new narrative where speed is the proof of the structural perfection of the system. The real universe surpassed the fiction of our doubts, revealing itself as a high-performance laboratory that defined everything that exists with a precision that leaves us in absolute silence. The synthesis is the acceptance that we inhabit a system of surgical precision where the speed of creation is the greatest evidence that the structure was planned by its laws. The dawn was a spectacle of instant maturity that science finally allowed us to quantify, revealing that the history of the beginning is a work of physical engineering of overwhelming and total greatness. The cycle closes with light, and in light we find the answer to the urgency of our own search for meaning in a cosmos that was born ready to be discovered.